Assalamualaikum and good day everyone. So for this video we will continue with part 2 and it is about empirical formula and molecular formula. Okay, so the definition, empirical formula, it is a chemical formula that shows the simplest ratio. So ini adalah keyword dia, empirical simplest ratio of atoms of the elements present in the compound. So for molecular formula, it is a chemical formula that shows the actual number of atoms of each element in a molecule. Okay, so the relationship between empirical formula and molecular formula is, so molecular formula is equal to empirical formula and times this n. So n, it is a positive integer. So n ni dia macam perkali lah. Okay, so how to determine this value of n? We can use this formula, n equals to molar mass divided by mass of the empirical formula. Let's have a look at these few examples. Let's say we have water molecule. So, empirical formula is H2O and the molecular formula is also H2O and the integer here is 1. Okay, so perkali dia adalah 1. Ini already in simplest ratio. Let's have a look at hydrogen peroxide. So hydrogen peroxide, the formula is H2O2. Okay, so we can simplify it into simplest ratio and it will be, the empirical formula will be HO. Okay, how to write the molecular formula? It is HO bracket N, which is the integer n is 2. And you will get the molecular formula is H2O2. Right, so for benzene, it is, the molecular formula is C6H6. Okay, if you want to write the empirical formula, it will be CH. Okay, so dia adalah simplest ratio. Okay, so let's say kalau you only given with empirical formula CH. Okay, so from the empirical formula ni actually kita tak boleh tahu more information because we don't know the perkali. Okay, so with the integer barulah kita tahu the actual molecular formula. Alright, so next kita tengok ethene. The empirical formula and the molecular formula is here, integer 2. Okay, so how to determine the empirical formula? We can use mass of the compound, or we can also use percentage of the composition of the compound, and the third method is we can also use combustion data. Okay, so ini agak complicated sikit, but we will go through the example. Right, so for the first example, 18 gram sample of hydrated compound contain 4 gram of calcium, 7.1 gram of chlorine and 7.2 gram of water. Calculate the empirical formula. Okay, so this question you are given with mass. So masukkan dulu info tentang mass and then number of moles, calculate the simplest ratio. Since you are given this H2O. So kamu kena tulis. Okay, tulis satu Ca, satu Cl2. Okay, Cl ada 2 and dot for H2O. Okay, so for H2O ni means it is hydrated. H2O kita tulis sekali. Alright, so how to remember this table? Okay, so first kita tulis mass, MA. So next, moles, mole. And then simplest ratio, Ra. So how to remember this? It is Ra. Ra. And remember, for ratio, you must divide the smallest mole. So for example, calcium divided by 0.1 because this is the smallest value. The next example, a sample of hydrocarbon contain 85.7% and 14.3% hydrogen by mass. Okay, so ini you are given in percentage and molar mass is 56. Determine the empirical formula and molecular formula of the compound. So for this one, since you are given in percentage, okay, nanti kita akan assume sebab total percentage adalah 100%. So we must assume, okay, so for this method kita automatically cakap untuk carbon ada 85.7 gram sebab kita dah pun assume the total mass is 100 gram. So 85.7 from the percentage adalah 85.7 gram untuk carbon. And untuk hydrogen 14.3 gram lah. Okay, so kenapa kita guna 100 gram, kita assume supaya senang untuk kita kira. Okay, so since you have the simplest ratio for carbon is 1 and hydrogen is 2, therefore the empirical formula will be CH2. Okay, so macam mana kita nak kira the molecular formula? Kita nak tengok molecular formula. Therefore, kita kena guna this formula, N equals to molar mass divided by empirical formula. So, N will be 56, which is the molar mass, and divided by mass of empirical formula, which is 12 plus 2 equals to 4. Therefore, kita tulis balik molecular formula. Molecular formula is equals to CH2 and kecil dekat situ will be 4. Therefore, kita expand balik, kamu akan dapat C4H8. So, this is the molecular formula. Okay, next, calculation by using combustion data. Alright, so for combustion data of hydrocarbon, dia mesti ada C and H. So, CX, HY. Okay, so in excess, oxygen will produce carbon dioxide and water. So, maksudnya CXHY burn in excess oxygen akan dapat CO2 plus H2O. Right, so combustion of organic compound pula will also produce carbon dioxide and water. Dekat sini dia akan jadi CXHYOZ. Okay, so let's have a look at this example. 1 gram of sample organic compound. So organic dia cakap. So remember tadi, kalau hydrocarbon CH, organic compound. Okay, so tadi hydrocarbon CH saja formulanya. And then kalau organic compound mesti CHO. Ingat, organic CHO. Right, so back to this question. Okay, so organic compound CHO was burned in excess oxygen. The combustion produced 2.52 gram of CO2 and 0.443 gram of H2O. Determine the empirical formula of the compound A. Okay, so for this question, okay, kita kena calculate step by step. So ada 3 step. Right, the first one kita perlu calculate the mass of carbon, and then kita calculate mass of hydrogen. Next, kita akan calculate mass of oxygen from the given information. Okay, so ingat organic CHO. So kita kena cari satu-satu dulu, barulah kita boleh masukkan dalam this table. So first kita cari mass of. Okay, so you are given with mass of CO2 2.52 gram. So kita nak cari mass of carbon. So kita kena calculate guna information about CO2, sebab dekat sini ada carbon atom yang kita nak cari. So just ikut step by step, kamu akan dapat jawapannya. Right, so untuk carbon, so carbon 12 divided by total molar mass untuk CO2 adalah 44. Okay, so times the total mass here, 2.52 gram, and then 0.6872 gram. 1 mole of CO2 equivalent to 1 mole of carbon atom. So CO2 ada 44 gram of CO2. So untuk calculate carbon, okay, carbon adalah 12 gram of carbon atom, dia punya molar mass. Okay, so from the question, so ini adalah from the question, kita tahu ada 2.52 gram of CO2. So ini yang kita nak cari. So boleh buat darab silang, and you will get the answer here, 0.6872 gram of carbon atom. Okay, so you can use whichever method that you prefer. Okay, so for the next step, you can use this formula, 2/18. Okay, 2 adalah untuk molar mass untuk hydrogen in H2O, ada 2, so kita darab 2 darab 1 divided by 18. 18 is the total untuk H2O molecule, times daripada total jumlah mass dekat sini, 0.443 the actual mass. So you akan dapat 0.0492 gram untuk hydrogen atom. Okay, so untuk mass of oxygen, kita kira yang paling last, paling akhir. Okay, so kita akan tolak mass of sample So mass of sample yang kita ada tolak mass of carbon dekat sini and tolak mass of hydrogen. Okay, mass of sample yang keseluruhan tolak carbon, tolak hydrogen yang kita dah kira dekat step 1 dan step 2. Okay, so you will get mass of oxygen atom. So 1 tolak 0.6872 tolak 0.0492 equals to 0.2636 gram. Now barulah boleh masukkan the value of mass dekat dalam this table. Guna Mamora table untuk cari dia punya empirical formula. So masukkan mass, mole and calculate the simplest ratio. Okay, so since your simplest ratio kamu tengok kat sini ada 3.5, 3 and 1. So kita kena tukar dia jadi nombor bulat, jadi whole number. Okay, so kita kena darab semua ni dengan 2 lah untuk bundarkan dia jadi the whole number. So ini akan jadi 7 darab 2, 3 darab 2 jadi 6 and 1 darab 2 jadi 2. So the empirical formula will be C7H6O2. Question, extra exercise. Try this one, try this 2 and also try this 3, and I will share with you the answers later in group.